Good afternoon. Today, as Patty just said, we're talking about optimizing BigQuery, and this is across kind of all functions and features within BigQuery. So, really trying to optimize from a storage and compute perspective. I'm Martin Barnes, and really my focus in CTS is on data platforms, data everything really, and looking to help you really leverage BigQuery at the heart of your data platform on GCP. And that's ultimately because BigQuery is a bit of a beast, which comes with a lot of power, but it also comes with a cost. And if you don't manage it really well, especially at the start, it can kind of seem like a bit of an issue. And really optimizing early, getting a few things right in the start of your journey can really help you move forward in a productive way. So it's important to think about BigQuery architecture and all of the decisions that we make when we're talking about BigQuery. And you'll see this picture a lot. Now, the important part of this picture for me really is about the distributed storage that's on the left side of the picture, and the compute on the right, which is distributed. And these two things are decoupled, and we can think about them separately, but also in a way that one enables the other. So if we get our storage layer correct, really it optimizes our utilization from a compute perspective. And from a compute perspective, if you make yourself kind of cause some challenges on the storage side in how you model the data, it can really create challenges on the compute side. And as a mentor of mine a long time ago said, when I broke a old Hadoop cluster, no brilliant SQL query can really work with the data that you've just created. So really optimizing the storage layer as a kind of principle to enable our compute is what our goal is as engineers and as users of BigQuery. So it's important to really consider that in every conversation that we have around utilization. And when we're creating everything from a data pipeline to just a general query that's using BigQuery, really thinking back to how do I optimize the storage layer to create optimal compute strategies and queries ultimately on BigQuery. So in terms of utilization, the largest cost for kind of most distributed data platforms comes in the shuffle phase. And within this kind of picture here, this is an example where we're reading some data, we're doing a general query on it, we're trying to filter that data down as much as we can, and then we're shuffling it to do a group. Now, the important phase here in terms of optimizing our queries really is to reduce the amount of data as early as possible within the first worker stages, because this is at a distributed state. So within this picture, really thinking about how do we reduce our shuffle phase to the minimal amount as possible. And if we have to shuffle, say in a group or a join, then how do we reduce early? So in this example, we'd be looking to reduce within our first where clause as aggressively as possible to reduce the network overhead, reduce the IO overhead, and ultimately increase the scalability and the performance of our queries. Because if we do that, we get the most out of BigQuery and we're able to do more within our allocated time, really on when we're creating data platforms. So key thing here is thinking about shuffle phases within our compute, reducing the amount of data that we're querying down as early as possible. And if we can reduce the shuffle completely, then that's really optimal in BigQuery and any other of the distributed data platforms that you'll be working with. Now, a key measure of this, and you'll see this mentioned across any BigQuery documentation or within query plans, etc., is the concept of a slot. Now, a slot is effectively an aggregation of your CPU, RAM, and networks. And you should really think of this as something when you get onto the BigQuery platform and start using it as a measure that you can attempt to reduce, but you don't have ultimate control over. On demand, you get 2,000 slots within a project that can be increased, or you could go to flat rate. And we see businesses really start with on-demand slot usage, and then as they progress in their journey, they then potentially move to flat rate if it's more optimal for their business. But what we want to be doing is making sure that each of these slots are really used as efficiently as possible, again, through making sure our storage layer is as optimal as possible to ensure that our compute layer and the queries that we submit to BigQuery are as optimal as possible, working with the storage layer, really to reduce the amount of slots that we use, or potentially even increase the concurrency that we can have by having more slots available. Another important part around BigQuery utilization is this concept of fair scheduling. And this is really where BigQuery looks to ensure that everyone has their fair share of compute resources. So in this example, we have a BigQuery instance where you've got 3,000 slots available. So this could be a business that's decided to go flat rate. And they have one dashboard. And that dashboard can use all 3,000 slots to be as efficient as quick as possible. But then our kind of famous data analyst who loves using BigQuery, the BigQuery service, comes in and submits a query whilst this dashboard's also consuming resources from BigQuery. And that person really then gets their fair share. So they get 1,500 slots available. And as we progress through our journey, we'll start to have data engineers come in, creating data pipelines, developing data pipelines, and putting them live. And that data engineer will then have their fair share of the resource. Now, as we're looking to increase our utilization on BigQuery, this is optimal, but at the same time can cause problems where each person effectively is diluting the pool. And for some use cases, this can create problems where your data pipeline may be sharing resources with your ad hoc analytics. And everyone's heard of the famous person that's come and basically broken everything because they've taken all the resources. So there's ways to protect that in BigQuery, and that's through slot reservations and flat rate. So for customers that are more advanced in their usage or require specific guarantees around their BigQuery utilization, slot reservations can be used to guarantee through committing to a flat rate of BigQuery slots. And the example here is that you've got a commitment, which is how many slots you actually need. They can be split up into reservations, which we'd recommend is usually based on your directorate or your specific use cases. And you assign those to projects within your GCP environment. So as we go in through the life cycle of someone who uses BigQuery, you find that people need more guarantee, less crossover of resource usage, and they then leverage slot reservations really to handle this use case. So in the example in the bottom right, we can see that this business has purchased 1,000 slots. That's kind of what they need for their BigQuery usage, and they've split it in and said data science need half of them, those resources. Our ETL processes need 300 of those slots, and our BI dashboards need 200. And what this enables this business to do is have confidence that their ETL processes won't be affected by the other processes that are running within their BigQuery project, and really provides them with confidence that they'll have consistent performance throughout their usage of BigQuery. So from a cost perspective, this can create an environment that is much more predictable, whilst on an operational perspective provides more confidence that projects can utilize the resources consistently and complete within more predictable timelines, especially in the ETL space. Now, like I said, these businesses tend to start on demand, and we absolutely would support that to understand your BigQuery utilization. It can be quite difficult at the start of your journey to really look at flat rate. But if you are a business that is looking at flat rate, we definitely recommend doing that. And come talk to us if you're potentially going through this project and life cycle within your BigQuery usage. It usually is quite high users in the on-demand space, but BigQuery is providing and creating some really good tools around estimation of what you require from a slot perspective. A few things that we would work with you on in this space, it really is about understanding how you've structured your organization. BigQuery leverages, obviously, project resource based models where we would want to map all of your kind of personas, your processing groups, your like logical group of users, and your use cases, your access patterns, really down to what resources do those people and those processes need to then build a mapping that would allow us to go more flat rate and create those reservation pools that really support your business. So the kind of tasks that we do are really around understanding your organization, around your usage, around your computational needs. But this is not a restriction. This is purely something that can add to your usage in BigQuery, provide more consistent utilization. So some things to keep in mind, really this changes the way that you could view BigQuery. Um, when you have fixed rate, flat rate, really you want to be utilizing that as much as possible. So potentially increasing the concurrency of your BigQuery usage. And we definitely recommend that you start to have a look at the new estimation tools around this space, because it leverages you to understand your BigQuery usage more, and potentially leveraging the combination of flat rate and fixed rate, flat and on demand as well. So it's obviously something that you can mix and match. So in terms of that compute and storage split, really it starts at schema design. And a few things to talk about within the schema design space is, as of now, right now, indexes aren't supported. And really that's because of the access patterns that BigQuery looks to facilitate around full kind of analytics aggregation scans. So partitioning and clustering in BigQuery is used really to optimize the access pattern into the storage layer. Additionally, and something that's really nice is when you use clusters, that can greatly reduce the amount of data scanned. And that's because of how clustering affects how BigQuery and the tooling within BigQuery will write to disk. And it'll really let you filter down the amount of data that you actually look to scan when you're doing a read. And lastly, around schema design, and this is something that I really want people to consider, is storage is cheap, so optimize for the solutions that you have, or the challenges that you have right now. There's not really any undoable mistakes in BigQuery. So if you're a Kimball focused business, a denormalized business oriented business, or a star schema focused business, that's okay. Usually just get onto BigQuery, start using the processes, understand BigQuery as well as you can, and then start to optimize in the future. Because at the end of the day, storage is cheap. And really look to utilize BigQuery fundamentally first before you start to really nail down on the schema design side of things. But if you are in a position where schema design is front and center of your business, BigQuery works very well with the concept of denormalization. And this is the idea that we can flatten out something that may be more of a star schema style structure, and really reduce the amount of shuffling that you have to do by reducing the amount of joins that you do. So we'd treat this as kind of a first principle where denormalization is really optimal within BigQuery, and really start to look at how you could leverage denormalization to reduce the amount of data that you shuffle, and increase the amount of value that you get from BigQuery. But this doesn't mean that it's a requirement. And I think this is another key thing. We see many, many businesses who have skills in the kind of Kimball and star schema space and really are getting a lot of value out of BigQuery, and tend to look at denormalization as something that they can optimize on the far right-hand side of their processing, and maybe manage more of their T of the ELT process, the transformation stage, using like tried and tested methods in the modeling space. So absolutely denormalize where you can, but don't think that it's a requirement when you use BigQuery. But if you do look to use denormalization, nested and repeating fields with structure and arrays are the way to go. And there's a lot of functionality within BigQuery to really support that way of working. And the last thing that I think I've said before, optimize to solve your actual problems and not your expected ones. And we really want to push that. This is about delivering business value and not just being tech focused for the sake of it. Let's try and bring and deliver innovative ideas using BigQuery, as opposed to trying to optimize to the nth degree and delivering less value. So absolutely consider these things, but it's not the goal of our data platforms. Our goal is to deliver value. Key design pattern in this space really is clustering and partitioning. If you don't know about clustering and partitioning is the process of splitting up data into logical groups that can be computationally advanced by only processing specific groups. So within the example on the right-hand side, being able to filter on day and only querying that day if you say where the event day is specifically referenced here. And then from a clustering perspective, Really, clustering is about optimizing the way that we write data down to disk to enable us to filter data more efficiently. And leveraging both clustering and partitioning really is optimal to BigQuery usage. And importantly, it's cheap, it's cost effective, both computationally and from a cost perspective. So look to leverage this as early as you can. Big anti-pattern to avoid, however, and really use partitioning instead, is this idea of table sharding, which is something that a lot of businesses do in more traditional databases. So really look to leverage partitioning above table sharding, because table sharding can become quite intense to manage, and really it's unnecessary in processing nowadays. From a compute, so we just talked about storage, but from a compute optimization perspective, I really want you to take away two things. And first of all, that is this idea of we measure compute in multiple ways. Firstly, by I/O and shuffle. In the I/O and shuffle space, really reducing the amount of data that we both read and shuffle across the network. And using specific tools that BigQuery provide to do this. So the first one of these, it really is start to get used to the query plan. It can look really intense to start with, but once you start to understand the query plan, and we can support you on this, it really helps you move to the next level in understanding your computational usage of BigQuery. The example here is really that we read off distributed storage into multiple workers, into multiple shards. We look to reduce the amount of data using filters within that first sharded layer. And as we aggregate up, we have less data to transfer across the network into a single shard where aggregation can happen. And then data can then be sent back to your client and you receive the results. Now, this is the idea that really reduce the amount of data early on. And when you join, you can then see within the query plan how much data you're aggregating, and reducing that number where possible is really optimal. So the big second takeaway that I want you to take out of here is something that I see misused quite a lot, and this is the concept of the where clause. Really simple thing that a lot of people get wrong. Now, within BigQuery, you want to be putting the most kind of filterable, most extreme filter first. So in this example, where we're viewing Stack Overflow comments, we want to be reducing on usernames because there's probably not many comments on the username. So by filtering on anonymous, we'll only get the anonymous users' comments first, as opposed to trying to find all comments that are around Java, which I'm sure there are hundreds of thousands, where there may be hundreds of comments just from a single user. So by putting the username first, we'll filter on that, reduce the amount of data within the first worker phase, and then having less data to filter in the second phase, which is trying to find mentions of Java within that single user. So BigQuery will assume that you know what you're kind of filtering on here. So look to understand what you're filtering on and how much data can be aggressively filtered at this stage. And it's a really simple trick to optimize your queries with very, very little overhead. You can see this in the query plan, which I think is great to see. The top example is showing that the read phase within a query is really much higher when you're filtering first on all elements that are like Java, whereas in the bottom example, you get a 4 or 5 times optimization by filtering as early as possible. And we can see that the read phase within a single stage is reduced heavily by doing this process. So understanding using where clauses effectively and being able to view this within your query plan really is key, and probably one of the takeaways, one of many computational kind of tricks that anyone in your business can really utilize.